Huh? Yeah, somebody? No, let me give the acceleration of okay, what is the question? So there's a wedge. A block of mass m is released from rest on top of incline at t equals 0, and the wedge is moved horizontally with acceleration a naught. You write it will be here. Huh? A naught 12 meter per second square. Find the time taken by block to reach bottom of incline. Block to reach the bottom of incline B. So here AB equal to 16 meter. Okay, you take some calculation. Yeah. Okay, look at this. So what we have a block is released from rest. At the same time, I'll start accelerating the wedge. Then it's asking after what time the block will reach at the bottom of the incline. So B is the bottom of incline. It's a very good problem. You can pick up either framer. That's what I'm telling you. The frame of reference will determine how easily you can solve the problem. Of a block to be a test, what should be the acceleration? Anybody? Okay, I'll give smaller value. A naught is there, no? Let me give small value. Yeah, that'll be enough. A naught. I'll make it 4. Huh? Calculations will be very easy for you. For block to be a test on the wedge, shall we just cross check how much acceleration needed? G tan theta. Can you remember this? G value is this one, tan theta, tan 30. One by root 3. So 10 by 1.7. Around you need acceleration of 5 meter, approximately you can say, more than 5, no? Then only the block will be at rest without sliding that one. But what we have acceleration, 4 meter per second square. So what will happen to block? Will it be at rest, slide up or slide down?
5.7, sir. Acceleration 5.7.
Oh, yeah, the acceleration of the wedge, if it is 5.7, then the block will not slide. Am I right? But how much acceleration is there? 4 meters. So what happened to block?
Slide down.
Will slide down. So he's asking now, what is the time taken by the block to reach the bottom of incline? So time, I think we know is absolute, no? In any frame, either in wedge frame or ground frame, time should be same. So you can solve this problem in either frame. Which frame will be easier for you? The wedge frame will be much easier. After some time, so somewhere at an instant of time, there's no other way here. You can't write directly some equation. So give one formula, I'll apply it, I'll get the answer. So here m1g sine theta, m1g cos theta, pseudo force, ma naught, normal contact, and if you see, if you check the ma naught cos theta will be less than m1g sine theta. So therefore it will accelerate with respect to incline. And what is this incline? Incline will also be accelerating. It's not that the wedge will be attached. Wedge will be continuously moving. Now the person on the wedge, what he says. The frame of references are very important here. What this person says, block slides down the incline. What about this person says? Wedge moves horizontally and block moves in a plane. Let's see that Y is commenting like this. Huh? So what are the forces that are acting along the incline? We'll calculate here. Along the incline. Now we will write this equation person P with respect to Q. I'm writing here along the incline. So what are the forces that are acting? M1g, mg sine theta minus ma naught cos theta. Component of pseudo force. Okay, all of you. I have to resolve, no? And if I show resolving again, you'll get confused. So ma naught, I'll resolve it. So ma naught cos theta equal to m ar. So this will be g sine theta minus a naught cos theta equal to ar. G value of g 10 sine 30 1 by 2, a naught value 4 cos 30 root 3 by 2 equal to ar. So this will be 5 minus 2 root 3. Then what is the time taken for it to slide? So shall I write AB is equal to AR TAB square by 2 because it is released from rest, no? So we know value of AB. AB is how much? 36 meter. 36. AR value is 5 minus 2 root 3 by 2 TAB whole square. So what is TAB? 72 by AR, acceleration of the block relative to wedge. Because person Q is solving the problem, no? Acceleration of block with respect to wedge. Okay, getting this one? So you have to work out this. So you'll get the time that one. Now I want acceleration of block with respect to ground. How to bring that? You have to really take help of relative motion, what you studied. I'll keep it nearby. No, acceleration of the block with respect to ground. In ground frame, we'll find out acceleration of block with respect to ground. Same problem. What is the next thing is I'm trying to find out acceleration of block with respect to ground. So here look at the wedge. Wedge is having velocity a naught. This is AR. So the velocity of the block I'll resolve along this one. So this will be AR cos theta AR sin theta. So small rough diagram. The wedge I'll show yellow color so that the lines you need not to get confused. What is the acceleration of the wedge? Acceleration of the wedge is A naught, no? Look at this. This is something very important. Like next week, the numericals, it's going to help you a lot. That's why in the now only you better have a idea of this one. So what we are trying to do, acceleration of the block with respect to wedge. With respect to ground, we'll find out what is here acceleration of block with respect to wedge. Acceleration of the block with respect to ground, how much it will be. That we are trying to find out here. So what is AR cos theta? Acceleration of the block with respect to wedge along x-axis. So I'll take help of relative velocity. Acceleration of the block with respect to wedge along x-axis. Anything towards right is positive. Should be equal to acceleration of block with respect to wedge along x-axis is equal to minus acceleration of wedge along x-axis. This already we know. And this acceleration of acceleration of block with respect to ground along x-axis minus acceleration of wedge with respect to ground along. This we don't know. What is acceleration of wedge along x-axis is plus A naught. I'll put the symbol. It'll be very easy for you. Try to see the symbol. Acceleration of block with respect to wedge along x-axis equal to acceleration of block with respect to ground along x-axis minus acceleration of wedge along x-axis. So what is ABX now? Should be equal to AR cos theta plus A naught. Do we know AR? Yes. We know AR value. So substitute here, you'll get ABX. Then what about acceleration of block with respect to wedge along y-axis is equal to acceleration of block with respect to ground along y-axis minus acceleration of wedge along y-axis. Our wedge is moving only along x-axis, no? This will be 0. This we don't know. Do we know acceleration of block with respect to wedge along y-axis? It is AR sin theta. So what is ABY? I'll substitute this value, then I'll come to this.
So downwards positive.
Wait. This is AR value. We know AR value, no? G sin theta. In Pathfinder, you do have questions where you need this background. That's why I'm just helping you with this AR value into cos theta plus A naught. So this will be G sin theta cos theta minus A naught cos square theta plus A naught. So this will be G by 2 sin 2 theta. 1 minus cos square theta. This will become sin square theta. Okay, fine.
So Could you do the same question in the ground frame, sir?
I'm doing in the ground frame only. First, I need all the accelerations, no? Then I can work out. I'm doing in ground frame. Huh? This is what I'm solving now. Present is ground frame. It's very difficult ground frame. That's what I'm suggesting you. The choice of the frame is very important in getting answer. Then along y-axis, acceleration of block with respect to wedge along y-axis. This one. So this is AR sine theta. Anything downward, you take positive. This will be 0. So ABY is equal to AR sine theta. What is value of AR? So what we derived? Let me simplify here. ABY is equal to G sine theta minus A naught cos theta into sine theta. G sine square theta A naught by 2 sine 2 theta. So what is the total acceleration of the block with respect to ground?
Sir,
Let me finish off, then you can. This is our answer. This is the acceleration of block with respect to ground. I think it will be really very problematic for you, no?
sir,
Yeah.
ABX should be GY to sin 2 theta plus A naught sin square theta, sir.
ABX, huh?
Yes, sir. Plus, it should be plus.
Yeah, plus is there. Huh? Okay, fine. I think somebody asked, sir, I'll do in ground frame. You see, what is the problem? In ground frame, it is moving. But again, how much displacement in ground frame? Again, big headache, no? This what all we did is in ground frame. Huh? Acceleration of block. I think it's really big trouble, no, for you. So therefore, the choice of frame becomes very important in numerical. See, I could have just stopped the question there only. I could have stopped the question there only. TAB, go to this one. But really, a student has to work out here. So whichever frame you want, you cannot pick up. The frame which will have least mathematics is what you have to pick up. Are you getting all of you? That everything is in ground frame. So what we have just found out only acceleration. Then again, what you should do, you have to calculate displacement. Still more big headache. Huh? So what you should do here now, you should calculate what is the displacement of wedge along x-axis, then how much of displacement of block along x, along y. So it's quite very comfortable, no? Getting answer here very happily. Fine. This is very often you're going to get this one. You are supposed to think. That's why I just introduced now only. In the next week, what happened when you solve problems, no? Almost around 30, 40 numericals, you're supposed to think like this. Whenever the wedge comes, you should have this background. Okay, let me introduce some person climbing the rope concept. You can work out few numericals on that also. No, person climbing a rope. say pseudo force is some unlimited concept. Any number of anywhere I can ask you that one. It's not that, okay, 5, 6 problems, this topic will get over. N number of numericals available. Person climbing a rope. What concept we have to apply here? Okay, there's a rope. Okay, there's a rope is there. So now a person is going to climb up the rope. He will put his arms like this. And he's going to climb up a rope, no? So let the mass of the person be mg. So his weight mg will act here. How we can climb up? What is the method? What physics is involved in this climbing up a rope? That's what we are trying to work out here. That's all. What physics is involved in climbing up the rope? Okay, now let's go draw the rope here. Rope. There's a rope. That one. So only a part of the rope. Let me show you. So when the person these are his fingers. Only with respect to fingers. These are the fingers here. That one. Now there's a rope. What actually happens to him? I'm just magnifying it here. So his weight will act. What makes it to climb up here? There should be friction, no? So you do one thing, you apply oil on the rope and try to climb. Nobody can climb. So there should be sufficient friction. That one. So how the friction by the rope, how the friction will act here, the direction of friction, I'll take green color, I'm indicating by friction. The friction on the person, the net resultant friction is what I'm showing it here, will be acting on the person like this all together. The friction at all, both the arms and at the particular legs, no. So let it be called F, that one. The resultant friction acting on the person will be F, that will be upward. On the rope, I had to show it downward here. This diagram very important. Once you can get this, rest all you can manage it. Say just a small idea based here. Now, what is this F you have to interpret? Friction on man by a rope. What about this? Friction on rope by man. Sir, we don't know friction chapter. So just have an idea. Friction means some resistive force it is. Now this friction, what it will do? It will try to pull, no? So altogether, if I'm, is that okay? This friction which is acting here on the rope. So this friction, what it will do? It will pull the rope, no? That's why the rope will become taut. That's why the rope will become taut. So how much now, sir, what about tension? S, there'll be tension. So what is the tension? Tension equal to friction only. And that tension is what will be acting on the person. That is what actually happens here. So here, instead of here, here to, I should have, I'll put it here, the friction here. Like this. So now the because of friction, when tension is set up by pull forces, no, the friction acting on the rope, what when we try to pull the rope downward, the string will become taut. So again, what is this tension? Tension is equal to F here. Now, if you take the rope as an internal, then what is the only this F will become internal, no? So here, if you look at this, what is the force acting now? So T is equal to F. So therefore, shall I say that nothing but tension acting on the person, and if when the person will move up, when that particular tension greater than mg, he will move up here. So for now, I'm saying that person will climb up. Then what is the equation you're going to write? F minus mg equal to ma, where this F is nothing but T. So therefore, T minus mg equal to ma. In books, they directly wrote this T minus mg. And most of you, 99% of students are T minus mg equal to ma, tension greater than is weight, then you'll move up. How the tension is set up is what you're supposed to think, no? 99% of students, we accept things blindly. So why string will become, why rope will become taut?
Sir,
Again, yeah.
sir, small doubt, sir. Here, tension is not acting on the person, right? It's the friction which is acting on the person.
Yes, and the tension is
On-
equal to F. Yeah,
That's it, right, sir?
yeah, that's what. Books, what happened, they directly gave tension. How that tension is set up in the rope is what? Because of friction. So therefore, what is actually acting on the person? The friction is what acting on the person. If that friction greater than mg, it will move up. And that friction is equal to how much? Is equal to tension. Are you getting the idea now? So nothing, like if you look at the mathematics, there's nothing wrong in that one. So when the person will climb up, when the tension in the rope is greater than mg, person climbs up the rope, climbs up a rope, and I'll put that sentence here. The person climbs up. But actually this is not correct, no? Better what you say. You should press the rope hard, so hard that the friction should be greater than weight, then he starts climbing up. Is it okay? So indirectly we are just saying that if the tension in the rope is greater than his weight, he'll climb up. If tension, if he applies a friction, if it is less than his weight, then what will slide down? I think you can see that's why, no, the rope climbers, they'll have some gloves, no, specific gloves, and also they'll apply some powder, no? Am I right? Those who are going for trekking. My younger brother stays in UK. He does trekking, all this. I often see his videos, no? He will apply the powder, that one. So I like, why that powder? To have more friction. Not like our talcum powder, Pond's powder, not that one. It's a separate that one. So that will provide more friction. So they need not to press not very hard the rope. With a gentle pressing the rope, what when a lot of friction will be generated with the help of that powder. So they'll apply that powder. So it'll be very easy to climb up. The persons are trekking that one. Not talcum powder. Talcum powder will make it smooth. So therefore, if I press the rope such that with a less force, then the friction become less than weight, it'll start climbing down. So when the person will climb down, I don't know why our books missed this idea, but something that friction is word missing is there. So students do end up with only idea of, so the person here now also the friction will be the friction on the rope. This is mg. When you slide down, mg minus F equal to ma. So again, what is that F? F should be equal to T, no? I will shift this diagram down. Okay, I'll extend the rope. It's not a rod to show all the forces. I'm making that rope thick. Don't take it another way. This I to show tension like this. This is actually the diagram. Huh? Should be like this. Here also the tension. The rope is thick, no? So therefore the diagram will end up like this. The T is equal to F here. That's the meaning of here. So the person climbs up the rope, or it all depends on this condition. Okay, everything is there at one place. Just do make observation. I will take one small problem based on this. Completed? Okay, no. So next we'll take some. This is a block M1. Okay, there's a light pulley, it is called as. And the rope is massless. The string is massless. I will release the two blocks. So I want to calculate the tension in the rope and also the acceleration of the blocks here. So first the weight M1G will act. M2G will act here. The string will become taut. So there's a method of showing tension. Then let M2 greater than M1G. Or so let M2 greater than M1. So this will be heavier, no? So this will accelerate down. This will accelerate up. So what are the equations now? We can write it. M2G minus T is equal to, after some time, what you see after some time, I release from rest. After some time, what we notice, the block M1 will be here. And the M2 will descend, no? You might have played all this when you were a kid, you might have played, it will have velocity V. Both should have same speed, they're connected by common string. So I'm interested in getting these accelerations now. Acceleration of that and also how much of tension. Okay, no. So let's write the equation. So M2G minus T equal to M2E. T minus M1G equal to M1A. I'll add up these two. So M2G minus M1G equal to M1 plus or M2 plus M1 into E, where acceleration equal to M2 minus M1G by M1 plus M2. So this is the acceleration of the block. So I want the tension. So let me substitute the value there. T minus mg equal to m1 by m1 plus m2. So 2m1 m2g by m1 plus m2. So this will be the value of the tension in the rope. And this is the acceleration. Now, why the block M2 will move up? It should move up. No, how much it will move up? That much the M1 will. How much M2 will descend? That much will depend. The M1 will ascend here. So if you look at this displacement Y, this will be Y only. Anything? Because again we put a condition. String is massless and inextensible. Massless and inextensible. So what is the length of the rope? Let me take the length of the rope, say 10 meters. Just a general discussion. Then let Y equal to say 2 meters. How much length of the rope here will be? 8 meters, no? How much here should be? 12 meters. So look at the total length of the rope. Same 20 meters. So how much M2 has descended? That much M1 will ascend. So therefore both should have same velocity, same acceleration. Got the idea? So like that, we are taking some very general, no mathematics, nothing. Some observation. You can choose if Y equal to 3 meters, then this will become 7 meters. This will become 13 meters. So there's a light pulley, it's a massless. Now you can ask, sir, what about tension? As it is a massless, so the tension, what happened, will be equal on either side. This is called like a Atwood machine. It's having some good applications. Okay, time being, so there's a one general introduction I'm giving for you, that one, how to calculate acceleration of the block and how to get the tension. How to calculate tension in the rope, this one. If the string is having a mass, then it'll become very little bit complicated problem, because mass on this side decreases, mass on this side increases. We have to bring integration into the picture. So now inextensible word, I think very important, no? The word inextensible plays very important role. How much of tension in the upper part of the rope? Shall I write 2T? If pulley is having a mass, then what happens? You have to enter into rotational mechanics chapter. Okay, any doubt you can just clarify.
Sir, yesterday's homework, sir.
Huh?
Yesterday's homework, sir.
Yesterday's?
DPP, sir. The DPP you sent.
That you have to work out part. DPP, I'll not help you. I'm not that kind of person
Sir,
where
doubt in that passage, sir.
everything, it's,
Sir.
yeah, better that one and all. So I'll not teach DPP. I don't have habit of teaching DPP, that one. I'll give it to student, clarify doubt. Because you'll become more dependent. That's what I feel. I want you to become independent. Maybe other subjects, the teachers may help you, but from physics side, what happened, the help should not be to extreme level. That's what I feel. Any doubt you can clarify in WhatsApp, that one, in DPP.
Okay, sir.
Okay, tomorrow, today I'll give some problems related to all this, what all I discussed, no? Like a non-inertial frame, pseudo force, then some monkey climbing up a rope, and this pulley is one. Atwood machine it is called as. I will give a name for this. It's called as Atwood machine. Tomorrow we'll combine a few more numericals. Everything will end up that one. So you can work out numericals. Yesterday I gave assignment. No? So again, they are based on equilibrium, that one. Just a basic idea, that one. So from year of fruits, you can see all the application problems: normal contact, tension, pseudo force, monkey climbing up a rope. All these mixed ideas will be coming. So you should know how to manage things.